Hi everyone, let us discuss this example. See, in this example we are going to find the value of surface integral of a scalar field. They have mentioned the given scalar field f of xyz is equal to x into y into z. Surface is also mentioned in this problem. So let me write the definition of surface integral of scalar field first. So we know that double integration f over s is equal to double integration f of phi of uv. So here a phi is a parameterization of given surface S, okay, and that phi is defined on domain D. So that's why we solve this double integration over domain D. After that we have phi u cross phi v du dv, okay, du dv. So this integration we have to solve. The most important thing is parameterization of a surface. We are going to find it, but before that let me write a given information. The given information is that scalar field. Let me mention here, we have, what have they given here? F of x, y, z is equal to x into y into z, right? And the surface is also clearly mentioned. So let me write and S is the surface of cone. What is the equation of cone? Z square is equal to x square plus y square. So if I put z is equal to 0 and if you solve it, we will have x is equal to 0, y is equal to 0. That means that cone passes through this origin 0, 0, 0, right? So let me draw a rough sketch of a cone. So it will be like this. So this type of cone we have, okay? Yes, this type of cone we have. After that, they have added here between z is equal to 1 and z is equal to 2. So we know that z is equal to 1, this is equation of plane. This is equation of plane parallel to xy plane. That means we have a plane here which is parallel to xy plane. Then definitely that plane will cut this cone into a circle. Getting? So here we have z is equal to 1. That surface will cut, z is equal to 1. That plane will cut this cone into this circle. I hope it is visible to you. So at z is equal to 1, we have got this circle. Getting? So that equation also you can easily find. If I put z is equal to 1 here, we will have the equation x square plus y square is equal to 1. X square plus y square is equal to 1. So this is equation of this small circle. As well as we have a second plane, z is equal to 2. Z is equal to 2. If you draw a plane here, z is equal to 2, which is parallel to xy plane, then that plane also will cut this cone getting into a circle. So z is equal to 1 here, obviously z is equal to 2 will be somewhere here. So that plane will cut this cone into a circle. That equation also we can easily find by putting z is equal to 2 here. X square plus y square is equal to 4. X square plus y square is equal to 4. Okay, so this is equation of circle with center origin basically in xy plane and the radius is 2. So we have to consider only that part of cone which is bounded by these two circles. Here is bounded below by circle, okay. At bottom we have a circle with radius 1 and at the top we have a circle with radius 4. Okay, so this is the surface we have. After that we have to find its parameterization. So see, in double integration and triple integration we have already seen when we have cone, when we have cylinder or when we have paraboloid, we go for cylindrical coordinate system. So here also I will do the same, right? So putting, let me write, or yes, putting x is equal to r cos theta. I am converting this problem into cylindrical coordinate system. So x is equal to r cos theta, y is equal to r sin theta and z is equal to z. So with the help of that we are going to find parameterization, right? But see, the problem is that in parameterization we reduce the variable. Here we have three variables x, y, z and new variables are r, theta and z. Again we have a three variables. Actually we should express it in terms of two variables. So for that I am going to use this equation. What is equation of this one? Z square is equal to x square plus y square. So that's why z is equal to square root of x square plus y square, right? So what will I do? I'm going to put these values of x and y here. So r square cos square theta plus r square sin square theta. Okay, so we have some space, let us use. See, what can we do here? We can take r square common. So if you take r square common, inside the bracket we will have cos square plus sin square, which is 1. So this is equal to root r square. Root and square will get cancelled to each other, and r, that means z is equal to r. So in this way we express x, y and z in terms of only r and theta. So you can consider it as a parameterization. Then parameterization of S, parameterization of S is, so it will be phi of r theta. Since we are expressing in terms of r theta, x is r cos theta, right? Y is r sin theta and z is r. So we have expressed in terms of r and theta, so that's why we are interested to find the limits of r and theta. So as you can see here, at the bottom we have a circle with radius 1, at the top we have a radius 2, so r obviously moves from 1 to 2. And to cover an entire region, theta should vary from 0 to 2 pi. It should be rotated by 360 degree, then the region will be, that surface will be easily covered. So this is the parameterization. After that we are going to do the further calculation, make a screenshot of it, then we will go further. So let us solve it further. So we have a parameterization phi, okay, we have this parameterization phi. So let us find its derivative with respect to r and theta. Then phi r, derivative of phi with respect to r. See, cos theta is constant, derivative of r is 1, so here we will have cos theta. Here sin theta is constant, derivative of r is 1, so here we will have sin theta, and derivative of r is 1. So now we will differentiate phi with respect to theta. So this time r is constant. Derivative of cos theta is minus sin theta. R is constant again. Derivative of sin theta is cos theta, and derivative of r is 0 since we are differentiating with respect to theta. So after that we find a cross product of this phi r and phi theta. Let us do. Then phi r cross phi theta. So when we have a cross product, we solve the determinant and we will have its value. So here also I will do the same. The first row is obviously ijk. For the second row, we take these three components of phi r, that means cos theta, sin theta and 1. And for the last row, we consider these three components of phi theta, which are minus r sin theta, r cos theta and 0. So this is equal to I. So you know well how to find the value of determinant. So product of these two, 0 minus r cos theta into 1, we will have minus r cos theta, right, minus j. For middle term always we have a minus sign. Product of these two, 0 minus product of these two, minus r sin theta. So minus plus r sin theta plus k. Product of these two, r cos square theta, right, minus product of these two, minus r sin square theta. So minus plus r sin square theta. So this is equal to, the first component is minus r cos theta, second component is minus r sin theta, and for a third component if you take r common, we will have cos square plus sin square 1. So r into 1, obviously r. So in this way we got the value of cross product. After that we have to take its norm. So let us do. So norm phi r cross phi theta, right? So this is equal to, so you know well how to find the value of norm. Square root of, I will do the same. So square root of square of first component, which is r square cos square theta, square of second component r square sin square theta, and the square of third, which is r square. So let me do it here. Square root of, so if you consider the first two terms and if you take r square common, we will have cos square plus sin square 1. So that means simply r square plus this r square, actually we are adding, so 2r square. So if you take separate square root, we will have root 2, and square root will get cancel of r. So we will have r. So this is value of norm phi r cross phi theta. You remember in a definition, after having the value of norm, we should know the value of f of phi of r theta. So let us find its value. Yes, I will do it here. Okay, we have some space, let us use. So f of phi of r theta. So this is equal to f of, what is phi of r theta? Let me put it here. R cos theta, r sin theta and r. After that, we have to follow the definition of f. The definition of f says f of xyz is equal to x into y into z. That means simply we have to take product of all these three components. So if you take product of all these three components, r into r cube sine theta cos theta. So now the everything is ready. F of phi of r theta we have calculated. Value of norm also we have got, which is root 2r. So simply we have to put all those values, okay, and in the definition if you put, and by solving integration we will have the answer. Okay, I'm going to do that thing. Just make a screenshot of it. Okay, so let us consider double integration of f over given surface S. Okay, so let me write the definition again. Double integration of f phi of r theta norm phi r cross phi theta dr d theta. So as you can see here, the limits of r 1 to 2. So r varies from 1 to 2, theta varies from 0 to 2 pi. Purposely I have kept all these things here, so we can easily put those values in the definition, right? Limits of r and limits of theta I have considered. So this is equal to integration 0 to 2 pi 1 to 2 f of phi of r theta. Yes, its value we have got here. So let me put r cube sine theta and cos theta. What is value of this norm? It is, yes, here root 2 r dr d theta. So what we do when we have any constant, we take it outside. So here we have a constant root 2. So let me take it outside. Root 2 0 to 2 pi, right? So first we integrate with respect to r, and then we will go for theta. R cube into r raised to 4, right? And integration of r raised to 4 is r raised to 5 by 5. So it is r raised to 5 by 5 with limits 0 to 2. We have this sine theta cos theta d theta. Okay, so let me remove this part, so we will have some more space to solve this problem. Okay, so let us put upper limit, lower limit. So if I put 2 here, root 2 is there. If I put 2 raised to 5 is 32. 32 by 5 we will have, and if you put 0 we will have 0. So let me simply mention 32 by 5. 0 to 2 pi sine theta cos theta d theta. See, multiplication is there, so that's why we cannot find its integration directly. So we need to use the formula of trigonometry here. Okay, I'm going to do that. Just let me write here. So we are familiar with one formula, that is sine 2 theta. Sine 2 theta is 2 sine theta cos theta, but for that we need to have 2. So we have already have 32. So I can express 32 as 2 into 16. Okay, let me do that so you can easily understand. Root 2 by 5. So 32, that means 16, and I am taking this 2 inside. 2 sine theta cos theta d theta. 32 we had. 32 means 16 into 2. So simply I have written 16 outside the integration, and I have taken 2 inside the integration. So why I am doing this? Because I want to adjust a formula. That formula is 2 sine theta cos theta is sine 2 theta. So this is equal to 16 root 2 by 5. So 0 to 2 pi. So it is formula of sine, it is sine 2 theta. Sine 2 theta d theta. So will you tell me the integration of sine 2 theta? Integration of sine is basically minus cos. So let me take it outside. I am writing minus outside, cos 2 theta. And whatever the multiple of theta, we should write in denominator. Multiple of theta is 2. So I am writing 2 in denominator. 0 to 2 pi. Okay, so actually the integration of sine is minus, but minus is constant, that's why I have taken it outside. So minus 16 root 2 by 5. So I should put 2 pi. So at a place of theta, so we will have cos 4 pi, right? Cos 4 pi. So cos 4 pi, I should mention cos 4 pi by 5. And if you put 0, so cos 0 is 1 by 5. So minus 16 root 2 by 5. Okay, so cos 4 pi, I should mention somewhere here, cos n pi is minus 1 raised to n. What is formula of cos n pi? Minus 1 raised to n. So we have cos 4 pi, that means minus 1 raised to 4, which is 1. Okay, which is 1. So that's why the value of cos 4 pi is 1. So let me write here 1 by 5 minus 1 by 5. But see, in a bracket we got 1 by 5 minus 1 by 5, which is 0. and 0 into anything 0, so that's why the answer, this value of this bracket is 0 into this one, so the answer is 0. So make a screenshot of it, then we will stop. Thank you. See you.